Enterprise Strategies Part 2, Scaling the ISO Server. In this nugget, we're going to fill out the rest of the cracks in the pavement, if you will, to make ISO Server a complete enterprise solution. The first thing that we're going to look at is implementing network routing options. Overall, with what we know so far, we have a primary connection to the internet. And if that connection goes down, we're out of luck. We don't really have any backup plan. So we'll discuss network routing, how we can configure it, how it relates to the ISO server, and some of the strategies you can use. From there, we'll get into a feature called automatic discovery. You ever open Internet Explorer when you first install a computer and you know it's connected to the internet, even a high-speed internet connection? It just kind of sits there. You're like, well, what's going on? And you're waiting for the web page to show up, and you notice at the bottom it says attempting to automatically discover proxy. And you're sitting there waiting for a good 7 seconds. Well, I'm going to show you how to actually make it do something during that process, because I know most of you stop it, go into the options, turn off automatic discovery, and never want to see that again. Well, I'll show you how it is a good feature in this nugget. Finally, we'll look at the fish, understanding and configuring CARP, the caching and array routing protocol, and making it work for you so you can properly distribute the load on your servers. So let's start off with the need for routing. In addition to the primary and backup internet connection scenario I was just mentioning on the previous slide, I thought of some other situations that I've encountered where routing could really come in handy. Let's take this first one on the top of the screen. I know it looks kind of cluttered. Let me break it down one at a time. In this area, we have a corporate office, a branch office, and the internet. Now, in the corporate office, we have an ISO array of X amount of servers and a T3 internet connection. Now, at the branch office, we have a T1 line to the corporate office and an ISDN 128 kilobit per second backup. Now, what we can do with this scenario is say, you know what? If my internet or my link to the corporate office is online, I want to use this and tag it as the primary. Why? Because they have an ISO server array there that probably implements caching features, and I can get most of my content that's commonly requested through that cache. Not to mention I can cache it at my own ISO server at the branch office. If this one goes down, however, we could go ahead and say, you know what, as a backup, I want to go ahead and route it off to the ISDN connection, 128 kilobits per second to the internet. Maybe slow, but it's better than nothing. Another situation might be this. You have an Australian office and an office in the United States of America. Same connection speeds. We've got a T3 line out of the corporate office, an ISO array that's a little more squished, and a T1 line across the sea to the Australian office. Now, in Australia, we also have a 128 kilobit per second to the Australian ISP. What we can do is define destinations and say, you know what, if somebody in the Australian office attempts to contact something, a website or some range of IP addresses that is located in Australia, well, it may end up taking longer, even though the connection speed is faster, to go over to the U.S., out the T3 line to the ISP over there, then back overseas, and probably even through the same ISP to retrieve the content. So instead, you can create a destination set and say, for these list of locations, define them all in a row, I want to use the Australian ISP as my primary connection. If it's not one of those connections, then I will go ahead and fail over to the ISO server array for all other requests other than this specific list. So that's a couple areas where you might want to implement specific routing. And I'm sure as you see us configure routing and set it up, you're going to think, oh, I could set up some different scenarios for my own company, because there's many situations where you may want to choose alternate paths to a destination over using your primary connection. Let's walk through the configuration of these network routing rules. And to do this, I'd like to do the scenario that I just described on the whiteboard. I want to have the Australian office with the 128K ISDN connection. I want it to go to a corporate office, and we're going to define the whole setup to make this work. You're going to love this because it's going to combine a lot of the knowledge from a lot of the nuggets together. I've went ahead and set up the arrays and named them appropriately. I have the corporate USA office. That was the array that had the 3 ISO servers or so with the T3 connection to the internet. And then I have the Australian office. And I'm going to focus in on Australia. I'm going to assume corporate USA is set up to correctly route to the T3 line, which is the default if you set it up correctly. I'll expand out Australia, and I'm first off going to do some preliminary setup. I needed to define what IP addresses I would like to route to Australia for, or domain names. So I'll expand the policy elements and create a destination set. And we'll just say these are the IP addresses in Australia. And I'll add a range. And we'll say the IP addresses from 150.223.0.0 up to 150.223.255.255 are available in Australia. And we'll also say, I'll click on add and say star.australia.gov are available in Australia. So just some ranges, some reachable things that I would use the Australian ISP for instead of using the connection through corporate America. I'll click on add and I've added the destination set. Now remember, destination sets on their own are nothing. Now I'm going to also define a dial-up entry to the ISIS server. This is going to be A, the backup connection, and B, the connection for those Australian IP addresses that I just defined. Now beforehand, I went on the Windows 2003 server in Australia and set up a dial-up entry in the control panel. So we'll name this one. I'll click in the box and name it ISDN link to AustISP. Okay? And I'll map it in the ISIS server to the dial-up connection I defined in Windows 2003. I'll also say the network dial-up account. We'll go ahead and say the username will be administrator, or whatever username I want. And the password it actually imported over from the ISP setup, from the control panel entry I defined in the actual dial-up entry. So I'll click on OK. And I've added now a dial-up entry to the ISIS server that it can use. Now let's get into the routing rules. Now we've defined our policy elements. Let's configure our network configuration. You notice that we have this routing folder, which can be deceiving. The routing folder, first off, you need to know this, is only for web requests. It does not handle FTP, does not handle ping messages. It doesn't handle anything except incoming and outgoing web requests. To set up the other features, we're going to go to another area. I'll discuss that in a moment. But for now, let's focus in on this routing. You'll notice over to the right-hand side we have this rule. It's the last rule, and it's locked in as the last, and name is default rule. Now you can change some options, a few of them on here, but you cannot delete this. What this is the rule that defines what we do for our requests if none of the other rules apply. And the action by default is to retrieve the request directly from the internet, check and see if it's available in the cache, and it applies to all destinations. The funny thing is we've been using this default rule in the network configuration all along, but not even known about it. This defines our primary connection to the internet. But now we're going to go a little bit beyond the primary and define some rules of our own. I'm going to go ahead and right-click on this routing, hit New Rule. And this one I'll name Australian Connection. This sounds kind of James Bondish. The Australian Connection. So I'll click on Next. And it'll say, what do you want to apply this rule to? I'll say a specific destination set. This is going to be for the destination set that contains the IP address and even that one domain name in Australia. It'll say, what do you want to do? How do you want to get the things that you've defined in that destination set? Do you want to retrieve them directly from a specific destination? And if I just leave this, it'll use the primary connection. Do you want to route to an upstream server? Do you want to redirect to a specific site? How do you want to handle this? Well, I'm going to leave this retrieve directly from specified destination, but I'm also going to check this box that says use dial-up entry. That will tell it now is the time to dial up that Australian ISDN connection. Use that dial-up entry. Now you may be saying, well, what if you have multiple dial-up entries? How does it know which one to use? Here's another tip. ISIS server can only have one active dial-up entry at a time. You can define multiple ones, but it can only use one that you mark as active. So hopefully we keep that one. Well, there's only one right now, but if we added more, we would have to make sure that the Australian ISP is marked as the active dial-up entry. I'll click Next. From here it's going to say, do you want to search the cache at all before you ever dial up that connection? Do you want to search and see if a valid version of the object exists, and if none exists, then retrieve it from the ISDN link? Do you want to check and see if any version of the object exists, even if it's expired? And if so, use that instead of dialing up the connection. Or does it say, do you want to use any version and never dial up the link? This is a way of limiting certain sites. Maybe you have some cached information that never expires. You could define a routing rule to say, I never want to connect to the internet, never want to route the request. I only want to get it from the cache. That is what that option is for. But I'm going to say I want to check if a valid option, a valid object exists. And if not, then I'll dial up the connection. Hit next. From there it's going to say, well, do you want to cache it? I mean, after we dial up, would you like to put it in the cache? Do you want all content, including dynamic? Only specific content that can be cached? This is pretty much if the source and request headers indicate it can be cached, do you want to use that? Or never cache the content? I'll say if it's valid to cache, that's fine. Now I've created my first rule. I hit finish. This is going to define that Australian connection and define that I only want to use the internet connection in Australia for that specific destination set. If it does not match that destination set, what it's going to do right now is fail down to this default rule at the bottom. Now I did mention that that default rule cannot be deleted, but I could change it and I could say if it doesn't match this Australian connection, then go ahead and route it to corporate USA. And I could modify the default rule, but that wouldn't be enough fun. We wouldn't see all the options. So let me create another routing rule. I'll hit new rule, and this rule will be our corporate USA connection. Okay, this will be if it's not in Australia, it's not in those ranges we defined, then I want to forward it to the array over in America. It's going to apply what? Now to all destinations, okay? It'll apply to any destination that's out there. And you might be thinking, well, won't that also include the Australian ones? Well, yes, it will, but I'll show you the importance of your rule order in just a moment. I'll hit next, and it's going to say, how do I proceed for this? Do you want to receive directly from the specified destination, or do you want to route to an upstream server? This is going to be what I choose in this case, because I want to route it up to the United States of America, to the array up there. Now the final option down here is to redirect, and this is a good security one. Maybe you define a routing rule for a specific destination set that contains websites you don't allow access to. You could redirect those to maybe a site that has a web page that says, sorry, you're not allowed. But for now, I'll say upstream server. Click next. Which upstream server or array? Now I could browse and find a specific server, or I could type the name of that array, and it will forward it on to that corporate USA array. So I'll go ahead and say corporate USA. What port is that array configured to receive on? And this is pretty much the port that it's going to receive incoming web requests from its clients, which is by default 8080 SSL port as well. If that array required us to authenticate to it before it would allow access, we could type in what account to use and what type of authentication it should use. But we'll say that it doesn't require authentication for its clients. I'll click on next. It says when the primary route is unavailable. This is cool. When this connection is unavailable, meaning you can't reach corporate USA, do you want to ignore requests and pretty much give them, sorry, page cannot be found, errors, that sort of thing? Or do you want to retrieve them from a specified destination or go to an upstream server? This is a backup route. This allows you to say, you know what, when all is said and done, if I can't reach it through corporate USA, by golly, that ISDN link is great. Even though it's slow, I want to use that as my backup connection. This will be the backup connection for all of your internet connectivity, not just the Australian IP addresses. I'll hit next. It's going to ask me the same caching questions that we saw with the Australian ISP. I'll hit next, cache it, that's fine. Keep the defaults there and finish. All right. Big point right here. As of right now, our order of these rules is totally wrong. It will process any request in a top-down list fashion. It will say, okay, I received a request. Let me check my first routing rule. Now remember, corporate USA applies to all destinations. So it will always match this one unless I change the order. I'll just use this move down button right here. Now we're better. Now we have Australia first, which applies, let me scoot over, it applies just to the IP addresses in Australia. So what will happen is it will receive a request, I should say, It will check and see if it's an Australian connection. If not, it then goes to the second one, which defines not only a connection to the corporate USA for all the primary connections, but also a backup. If corporate USA is down, it will fail over and dial the Australian connection as the final one. This last rule at this point is now meaningless, because if the corporate USA connection is down and our backup fails, then we don't really have any connections left in Australia, and Australia is, I had a temptation to do a Crocodile Hunter impression there. I will save you the grief. Right. Now you remember that these routing rules apply only to the web requests. What about the firewall and the secure NAT clients that can go beyond web requests and access FTP and ping and ICMP and all the other protocols that ISA server can support? Well, they are not configured from this routing area. They're not as flexible, believe it or not, as the web request. Those are configured from the network configuration. You right-click it and go to the properties. In this, we see the firewall chaining option. It says, use this page to specify how requests from firewall and secure NAT clients are forwarded to upstream servers. So these are the non-web proxy clients. This, again, doesn't give us as much flexibility. It says, to route requests to upstream servers, do you want to use your primary connection, a dial-up entry, or do you want to chain to this computer? In this case, again, we're not even given the option for an array. We have to select a specific server. This is the one that's located in the United States, what account we would like to use, and if we want to use that dial-up entry to get there. This is how we define our network configuration failover, or not really failover, but our primary connection for firewall chaining. If we're using another protocol other than HTTP for web requests, this will be the configuration it looks at and uses for its network configuration. All right, let's change gears a little bit and get into using automatic discovery. Now, if you're like me, I'm sure there's been many times where you've opened Internet Explorer when it's a brand new install, and you sit here and you see this detecting proxy settings down at the bottom, and you fiddle your thumbs, and you're like, what's it doing? And you finally get fed up. Stop. Tools, Internet options, connections, LAN settings, automatically detect settings, uncheck that just to spite it. You know it probably takes just as long to do this then for it to finally time out. But it finally feels good to hit OK, OK. Now it will never pop up and say detecting proxy settings again, and we can go straight to the Internet. Now what if I told you we can make something happen when it's detecting the proxy settings? What if I told you this can save you a ton of configuration time for all of your clients that are attaching through the ISIC server? So here's the story. You're going to have all of these clients in your network, and in this case we have 1,000 clients, that if we're running web proxy or firewall configuration clients on there, we have to set them up to connect to the ISA server. And what that means is you, as the administrator, need to walk to every single one of these computers and configure it manually to point to that ISA server. And that's all fine and dandy until the name of the ISA server changes, or the IP address, or maybe you disintegrate the array that they're connecting to and reconfigure it. That means that you get to go out again and reconfigure all 1,000 clients to connect to the ISA server. Or take this. Imagine that you have a roaming salesperson, is my best impression of a laptop, that goes from location to location. And when they're at this location, we'll say it's Denver, they connect to this ISA server and they use that configuration. But as they go off to Nebraska, they connect to a completely different ISA server and a different location. And as they visit Arizona and California and go to each and every location, you have to go and reconfigure that laptop to point to the correct ISA server. Truth be told, unless you're using secure NAT clients, which solely rely on a default gateway, you will need to manually configure that client every single time something changes on the ISA server or the location of the client changes. That is why we have automatic discovery. That is why you go through the pain every time you open Internet Explorer for the first time of it saying discovering proxy server, and you're thinking, what is it doing? Well, what it's trying to do is figure out where an ISA server is on the network so it can configure itself automatically. Now, the reason it always sits there for about 5 to 10 seconds when you first open it is because it's not finding that configuration. ISA server won't do it by itself. It needs the help of a DNS or a DHCP server. You can configure both to support this, but you only need to configure one. What you are configuring it to support is a feature called WPAD. It sounds kind of funny. It's the Web Proxy Auto Discovery Protocol. What happens is the clients are going to look for a DNS entry or a DHCP option that points them to the IP address of an ISA server where they can download their configuration as to what array or what group of ISA server or what single ISA server they're supposed to be pointing to. That means that you can simply discover or configure a single option on the DNS or the DHCP server, and it will automatically configure all 1,000 plus clients in your network. As this laptop comes into the location, it needs to use DNS or it goes to DHCP and reconfigures itself automatically to point to the correct ISA server. So let's talk about how to configure this. Here's how it works. Normally, you have to configure all your firewall clients and all your web proxy clients manually by hand to connect to the ISA server. That means, in this case, we have 1,000 clients sitting down here. You'd have to go to each one of them and say, this is your ISA server, this is who you connect to, this is their IP address or array name or whatever configuration you set up on those clients. Now, here's a couple problems. First off, unless you're paid by the hour, configuring 1,000 clients will take some time. Second off, what if the name of the ISA server changes, or the IP address, or the array name changes? Or here's another scenario. What if you have a laptop? This is my best impression of a laptop down here. Don't laugh. If you have this laptop that roams around between this ISA server network and some other ISA server network in Nebraska as it moves from location to location, a roaming salesperson. Well, every time that salesperson moves, you'll have to reconfigure their laptop, unless they know how to connect to the ISA server at the location they're at. Automatic discovery, what it does is it allows the ISA servers to discover, or I'm sorry, the clients to discover exactly what ISA servers they will go to. The way it does that is by using either DNS or DHCP. Here's the idea. Microsoft has coded this protocol called the Web Proxy Auto Discovery Protocol. It's abbreviated WPAD. Okay? You can configure a WPAD entry on the DNS server over here on the DHCP server to actually assign the client so that they can find the ISA server. Once they get that WPAD entry, they'll go to the ISA server that it's specifying and download their complete configuration. And I'll show you how to set up that configuration in a little while that they can download. But let's focus in a little bit more on what it means to configure WPAD information for DNS or DHCP server. Configuring auto discovery isn't that bad at all. There's actually 3 major steps. First, you need to configure the ISA server to support it. It's a simple checkbox. Second, you need to configure the DNS or the DHCP server to support it. Now, if you want both for redundancy, that'll be fine, but it's only required that you configure one or the other. Then third, you need to configure the clients. If the clients have disabled their auto discovery feature, you need to make sure they are re-enabled so that the clients can use that auto discovery feature on their end. So let's focus in on the server side first, on the ISA server. We can go ahead and enable it for any array, or this very well could have been just a single standalone server name if we would have rather done that. But I'm going to enable it for Australia. I'll right-click Australia, the name of the array itself, and hit Properties. Now it's very easy to discover the tab for auto discovery. You click it, and all you need to do is check this box to publish automatic discovery information. This allows the ISA server to say, hey, I'm going to make this available to my clients if they request it, and give them the configuration that they need. Now you notice it says use this port for automatic discovery, and it's defaulted to 80. I would really recommend using that because changing this prevents clients from using DNS for auto discovery. The DNS server will point them straight to port 80, and if you change that, you'll only be able to use DHCP options. That's all you need to do initially on the ISA server to support auto discovery. It now will make the configuration available to the clients. Now we will have to come back here and actually set up what configuration we want to make available. But for now, let's focus in on the DNS and DHCP side. If you'd like to use DNS to support auto discovery configuration, what you need to do is create a specific resource record. Right here, this DNS server is supporting the nuggetlab.com domain. And what I'm going to do is in nuggetlab.com, I'm going to right-click and hit New alias. Okay? You need to type it exactly as I'm typing it right here, WPAD. The clients are going to be requesting an alias of WPAD, and what it needs to point to is the fully qualified domain name of the ISA server. So in this case, the server's name is 2000server.nuggetlab.com. I click on OK, and that's it. That's all I need to do on the DNS side of things is make this alias available to the clients so when they request it, they can be pointed to the correct location. If you would like to use DHCP to support these options, you need to add an option to it. I mean, options are really how DHCP assigns everything. The default gateway, the DNS server, Win servers, all of that is assigned through DHCP options. And what we're going to do is right-click on the server that we'd like to hand out this option to the clients and go to Set Predefined Options. This is where it will list and let you modify all of the options that this server can potentially hand out. It's not going to be in there by default, so we need to add our own. When we click on Add, we're going to name it WPAD, just like before. The data type, instead of being a byte, will be a string of information. The code for this will be 252. All of our ISA clients, our firewall and web proxy clients, are going to be looking for that option in all their DHCP information they receive from the server. Oh, by the way, clients that are not configured for web proxy or firewall clients, we'll just ignore that. So don't think everybody has to support it in order to add this code. It won't mess anybody up. If they don't understand it, they'll just ignore that option. You can go ahead and add a description. I'll say ISA client auto discover to the description so we can instantly look at it and know what it is. So I've added this option to my DHCP server. Now I need to type in what value it's going to hand out. And the way this syntax is going to work is we type in HTTP : the name of the server that will be supplying the auto configuration. We'll say 2000server.nuggetlab.com /WPAD.dat. We're essentially directing it to a file that's going to reside on the ISA server that's automatically created called WPAD.dat, and that will be where the client ends up getting its configuration. That is how we set up DHCP for automatic discovery. It is ready to go from the option point of view, but it's still not configured to hand it out. We just added the options to the DHCP server. We still need to go to the scope options, right-click it, go to configure options, and say, you know what? In addition to the default gateway, in addition to the DNS and the Win server information down here, I want to scroll all the way to the bottom and also hand out that WPAD information. That allows you to say, for this scope, for the range 192.168.1.0, I want you to hand out WPAD with every single address that you hand to a client. We are now good to go from the initial server side of things. Let's take a look at the client. If you're wanting to configure a web proxy client to support this automatic discovery, we already went to the screen that allows it. You need to go to the Properties of Internet Explorers, Connections, LAN Settings, and ensure that this automatically detect settings is checked. You can eliminate this hard-coded configuration. This is going to be the piece that lets the Internet Explorer client download its configuration from the ISA server. If you're using a firewall client, let me go ahead and switch over to my client application. If you're using the firewall client, you need to double-click this little icon or go to the control panel and open it, and check the box that says automatically detect the ISA server. That pretty much says, yeah, I'm not going to use this ISA server. I'm going to download my configuration from the ISA server on my network. And that's what they get from the DNS and the DHCP server. The final step is going to be going to the ISA server itself and configuring what options you want to send these clients, because pretty much the clients are now configured to find the ISA server via DNS and DHCP. The ISA server, we went ahead and said, I want to publish the auto discovery information, but now we have to tell it what information to publish. The ISA server has the capability to publish the configuration information for the web proxy client or the web browser and the firewall client. So let's look at what options we have. first off, under the web browser, the default one that is checked is Configure Web Browser during Firewall Client Setup. So that means when you're installing the firewall client, it will automatically configure the web browser on that computer to point to this server. So Shazam, it's instantly a web proxy client as well. Down here we have the auto configuration. This is pretty much the section that I'm going to focus on because this is what allows it to use the DNS and DHCP configuration we just did. By checking this box, it now tells the web proxy client that you can automatically discover the settings that are set right here. So by checking this box, the web proxy client using the DNS or the DHCP configuration can point itself to this server and this port number. If you want to change the server, you can go ahead and do that. What offers a little more power is this one. Set the web browsers to use the automatic configuration script. We'll get more into this one when we get into CARP in just a few minutes, but overall, this allows it to script the web proxy client to allow for backup information and to support a lot of the caching capabilities to distribute the load. Using the default URL is usually the best way to go unless you are into scripting and you like writing your own scripts. You can create a script and use one that you specify down here. This is the default URL, by the way. But overall, my question would be why? ISOServer generates the script for you, and it does nearly everything that you would want it to do. It allows you to have backup ISOServers, pretty much point to an array. It allows you to configure it for caching load balance, and that's what we'll talk about a little more later. Overall, this is usually the best one to use with the automatically discover settings to allow for backup information to propagate to those web proxy clients. Now we also have direct access. If you want to configure the web proxy client not to go to the ISOServer, this is how you do it. And I think we saw this one in a nugget quite some time ago when we were talking about backups. One of the areas is bypass proxy for local servers. That pretty much says any range that's defined in the LAT, it will not go to the ISOServer for. Directly access computers specified in the local domain table. That's one we talked about before where we could specify domain names under the network configuration that it will not go to the ISOServer for. And then we can also add certain IP addresses, domains, or computers to a list that the web proxy will avoid when it's trying to access local devices versus things through the ISOServer. Finally, you have a backup route that you can configure. And you notice here, these settings will be applied to web browser clients that use the specified automatic discovery script. So in order to use that script, or to use the backup route, you have to ensure that you're configuring it to use an automatic configuration script. And this will allow the client to use direct access, meaning the client must have some sort of dial-up or direct network connection, or it will go to an alternate ISA server, and you can specify that one here. That is how you can go ahead and configure the web proxy client. The firewall client is much simpler. If we double-click the firewall client, it will bring up its properties, and all we need to set, this is pretty much when we install a firewall client, this is the default. It will DNS, look up the DNS name ISOServer to connect to the ISOServer computer. The checkbox we are going to look at is this one. Ching-ching. Enable ISA Firewall Automatic Discovery in Firewall Client. This allows the client, once it has that checkbox checked I just showed you a moment ago, to automatically discover this. You won't need to configure it at all. When you install it, it will go out of the box. For the ones that are already installed, you need to check that box to allow it to discover all of its settings. This application settings pretty much allows it to say what services this one supports. And we talked about this one way back in the client nugget, but you can go ahead and add your own services that you want to add for the firewall client to support. And you can see Net2Phone, Real Player, things like that are in here by default. You can add any custom service that you want to. That is how you can configure the client side of the server to say what settings should those clients use when they connect through the ISOServer using automatic discovery. And that, in essence, is how we make automatic discovery work. So let's look at the final scalability strategy as we make the move into understanding and configuring CARP. As I've mentioned before, CARP stands for the Caching and Array Routing Protocol. This is my little CARP over here on the right-hand side. What it does is it allows you to distribute the load of caching between multiple ISOServers in your array. Now what we have here is we have 3 ISOServers that I've combined into a single logical array. Now what happens is as I enable CARP features, it will combine the cache into a single logical entity between all of these. What will happen is all of these servers will then keep track and keep watch when servers are added and removed from the array. They will then distribute the cache logically. And the way they do this is based on the URL of the cache. Now, it's not quite as simple as this, but you could have a URL come in saying this is HTTP msn.com. Okay, and it will say, okay, I'll run that through a hash algorithm, and based on the results of that hash, it will be stored on the ISA2 server in this array. And pretty much you can go ahead and decide how much load each one of these servers should handle. CARP allows you to specify the load that should be handled by each server and how much hard drive space should be incorporated into that. And all of that is added into this hashing algorithm. It combines the URL with the hash, pretty much figuring out which server it should store it on, and finally puts it on a server, so you never have duplicate content between them. Now, the great thing about CARP is that the client PCs that are configured for the web proxy with the script. Remember, we just showed you how to configure it for auto discovery and then also showed you to automatically configure it with a script. These client PCs also have the same hash. So when they go to a URL, http://MSN, it's going to be able to run the hash on the client and figure out which ISA server it should go to get there. This is much faster than maybe sending a query to the default gateway and it having to figure out where to go and return the request from you. You're going to end up with double the load by doing that. If you do not have that script, then it is reduced to that method. You will end up querying a server and it will forward you to the correct server that you should belong at. That's the idea of CARP, and that's why it's so handy to configure the web proxy client to receive that script from the ISA server so it can do the hashing on its own. Configuring CARP can be done in two simple steps. First off, you have to enable it on the array as a whole. And by default, it's turned on. So unless you've configured something differently and turned it off, you should be okay. But this is where you need to go. You right-click on the properties for the array, and you'll come in here to the outgoing web request and ensure that this resolve request within array before routing is turned on. It would have been much more logical if it said enable CARP, because that is what this does, is it ensures that all of the load will be distributed between all of the servers in the array. From there, you get to go to the servers and say, well, how much load should each server handle? I'll go under here into the computers, and we only have one server inside of here, but you'll be able to get the idea. I'll open the properties for this ISA server, hit the array membership, and this is the load factor area. It says this number indicates the relative cache availability of this server compared to the rest of the array members. The key word is relative. The number that you type in here is the load that it will receive relative to the numbers on all the rest of them. We have 100 typed in here right now, and let's say we had another server inside of here that I had typed in 400 as the load factor. That would mean that this would store 1/4 and handle 1/4 of the cache requests as the other server that had 400. So really what you would do is, based on all the servers that you put in there, you would just, in your head, write down what you assign each load factor to be. Kind of add them all up and divide by the total number of servers to get how much load each one of those will be handling per server. That's the whole idea behind the load factors. Make sure you don't get confused and think that this is a value from 1 to 100, because it really is relative based on how you configure the rest of them. Once you do that, you're done. CARP will kick off and take effect. It really is an automatic process, and the only way that you can make it more efficient is by setting all the web browsers to use that routing script so they can participate in the efficiency of CARP by routing it to the correct server the first time rather than being redirected once they route it to their default gateway. And that's the magic that makes CARP work. So in this nugget, we have taken a look at implementing the network routing options, ensuring we have backup routes available, and making the routing more efficient, especially if we're in a local area that has a certain range or a certain domain that we would rather use a certain exit point on our network rather than the default. We talked about using automatic discovery, you know, that annoying feature that Internet Explorer has when you first power it on of automatically detecting where to go. Well, we can use that power to our advantage and have the client configure itself to point to the ISA server. Finally, we looked at CARP, the Caching and Array Routing Protocol, and how it makes our network more efficient. I hope this has been informative for you, and I'd like to thank you for viewing.